All right, everyone. I am here with Eric Horvitz. Eric is the Chief Scientific Officer at Microsoft. Eric, welcome to the TWiML AI podcast.
Great to be here, and thanks for having me.
I am really looking forward to our conversation, and I'd love to start it off by having you share a little bit about your background and how you came to work in AI.
Thanks. Well, I've had a long interest in how the brain works, how the mind works. I think this is these are some of the earliest questions we ask ourselves as kids. Going into as an undergraduate, I was interested in biology and the origins of life, some basic questions. I did a degree in biophysics. I went off to do an MD PhD in neurobiology, in neuroscience. Um, Largely because as I got into my junior and senior years at college, I started working in a lab where I would, a neurobiology lab, where I would actually pull micropipettes, they're called little electrodes that can get into the neuron of brains, in this case of little animals, and listen in to the clicks and the clacks, action potentials. I started getting more and more curious about brains. So I wanted to go through the MD PhD path. I thought that would give me access to people someday. And I was interested also with growing interest in biomedicine. And at Stanford, where I started my graduate work in the first 6 or 7 months or so, I started making a commitment to moving more towards computation because I thought more and more that we wouldn't get great insights through sticking little electrodes in brains for 1,000 years, then might as well go to the mathematics side of things. Yeah, I remember thinking that what I would do if I was to stay on the MD PhD path in neurobiology would be kind of akin to taking a little copper wire and putting it into a chip, the motherboard of in those days, an Apple II computer, and try to figure out the operating system. And I just didn't want to be going there. I thought I had better insights to jump ship towards computer science. And then I just said, remember that moment where I was in CS and doing classes, and I said, this is what I want to be doing. It's getting me some insights about what mind might be and how computation might lead to it.
It's interesting that you describe that transition. I think some of the most interesting conversations I have on the podcast are ones that explore this interplay between the biology and what we're doing on the computational side, and the two-way intellectual street between the two fields of study.
Absolutely. And you might say that in both cases, and of course they're related, there's this interesting magic we don't understand, that the bio and how bio makes minds. And then we have this mechanism, machine computing side that we actually can make progress on and understand. And we're always facing off at this big mystery and getting, we hope, inching towards it. But sometimes the chasm is even dark matter. We don't know how far away we are from getting there.
Mm-hmm. Mm-hmm. Among other things, you've been very involved in a number of industry organizations, including the Association for the Advancement of AI. I think you probably didn't go into all that because if you listed all of them, we'd be 40 minutes in.
Yeah.
But one of and I think you were president at one point. And in 2009, you, as part of your involvement in that organization, kicked off a study of AI ethics, which is going to be one of the themes that we dig into in this conversation. I wonder if you can maybe tell us a little bit about that effort, how it got started,
Yeah.
what the context was for it.
And it's funny because it seems so over the top back then when I proposed this. But so when I became president of AAAI, you basically it's kind of a process. You're president-elect, then you're president, then you're past president. So it's multi-year service. But when I came in, it's interesting. It's also a reflection of where AI was in 2007 to 2009 was my kind of term.
Mm-hmm.
And I decided to make the theme of my presidency AI in the open world. And what I meant by that was, let's take what AI is coming out of the laboratories, and it's getting useful, it's getting real. And the open world, as I like to refer to it, is pretty complicated. It's much bigger than our systems can represent. It's much more complicated than our laboratory environments. Might we build systems on the technical side that have the ability to understand their limitations, such that they're humble and know what they don't know? And might not this be one of several technologies we need to master to get systems to be robust and reliable in the open world, if they weren't just so overconfident and brittle and fragile?
Mm-hmm.
And so I gave my presidential lecture on that topic of where we had to go as a field. Presidents at AAAI gave a lecture one of their years of their office. And then I also proposed that we needed to sort of come together as leading AI scientists and think about the implications of our technologies on people and society, the influences broadly about what it would mean for ethics and law and safety. And this was a time when people were reading books by, and they probably still are, by Ray Kurzweil and Singularity Coming. And there was this kind of utopian view of what AI, where it might go, as well as a dystopian view, kind of being bantered about. And I thought, we haven't really weighed in as folks that are committed to the technology, as the scientists who you think should be responsible for where the technologies go. So I called together about 25 people that I chose, especially for diversity and also for knowing them quite well, as being these people would be committed to figure things out and wouldn't say I was crazy for asking questions about long-term AI advances, as well as ethical and legal challenges, as well as short-term disruptions. And so we broke this group up into 3 different working groups: short-term disruptions, long-term AI futures, and ethics and law. And for several months would meet. We all came together in February of 2009 at Asilomar. That was symbolic. That's where the biologists had met a couple of decades before. Talk about recombinant DNA and what it would mean. And it was 2.5 days of fabulous meetings, covering multiple topics. And that was the first time I even heard from working groups. I even heard this phrase, I remember, from the short-term group: criminal AI. It's like, whoa, what is that?
Mm-hmm.
Criminal uses, malevolent uses by nation, state, and non-state actors of how you could use AI now, with these new kinds of information feeds coming together from consumer uses of AI, for example,
Right.
and data sets and connectivity. We also looked at, on long-term AI futures, addressing the concerns of dystopian futures, losing control of AI. We hear from in books like later that came out, like from Nick Bostrom and others.
Super interesting.
So I actually asked somebody, one of the members who's a very good, fabulous scholar. I said, "Hey, look at Asimov's laws of robotics, and could we implement those laws in constraints and preferences and really field a system we could completely trust to do the right thing when it came to safety?" And we had other issues as well in law and so on that became, again, were, I would say, foreshadowing of what came of this area. By the way, speaking of disruptions and possibilities, on the first day of that Asilomar meeting, I invited 2 people who I thought would be the best able to answer this question. And it was Andrew Ng at the time,
Mm-hmm.
and Tom Dean, who's then at Google. I said, "Can you tell us, what surprises were on our horizon in the near term? Like, what would surprise us as AI researchers?" This is basically 2009 in February, and they both gave deep learning talks, which was kind of exotic at the time.
Yeah.
Supervised and unsupervised learning. And that summer, literally, it was like that summer in July and August, deep neural networks were were found to basically be have interesting power that was not leveraged in the past because we just didn't have the data sets to do it. And
Mhm.
that's when we saw the explosion right after they were in a workshop in October, and boom. So they predicted a surprise that was going to have big
Mm.
effects.
But that's still even 3 years before what we often think of as the real explosion with ImageNet in 2012, right?
Right. Well, I think what happened was, per my lens on the situation at the time, was and there's a funny story behind this involving Jeff Hinton and me. But I'm not going to go there exactly unless you really probe on that. But Jeff Hinton joined us at Microsoft
That sounds like a
Research.
challenge.
Yeah, right. Jeff joined us at Microsoft Research that summer, our we looked at our speech recognition and word error recognition rates, and we saw this jump on a data set called the switchboard data set that
Mhm.
had been flat in terms of the people hammering on it for a decade. And we said, like, like this was a big deal, and this happened at MSR, Building 99 here at Microsoft, and that led to a workshop in the fall that was really brought people together to say, what was going on? Like, how did this happen? And that was the path up towards ImageNet and so on. But it came out of, and the discovery was, by the way, and we're off the track a little bit of the ethics and responsibility, but
Mhm.
might interest your listeners. The discovery was that because the methods weren't that different from the neural nets of the late 80s and 90s, early 90s, but the discovery was these neural nets had been famished all these years for data, and we
Yeah.
just didn't know it.
Mhm. Mhm. And so the so you kicked off this effort in 2009, and what was the scope of it? Was it limited to this meeting, or was it a long-term study? How did you approach thinking about this issue?
Yeah, I thought it was exotic enough just to have a multi-month single study with a simple report that we wrote. There's a web page on the event. We did a report out at the IJCAI conference. It's another international meeting the following summer. Got lots of interest and response. That briefing led to an article that was surprisingly on the front page of the New York Times about our gathering, above the fold, as they say. And it created all this excitement and fear, as well as, questions.
Mhm.
I remember the phone was ringing off the hook when a headline appeared, something along the lines of, you can still find this online as this New York Times piece, like AI scientists discuss how machines might outsmart man. That was kind of the headline. You can imagine that, we get calls from all over the major news,
Mhm.
organizations and so on. Like, wait a minute, this wasn't like a crackpot. This was a group of scientists saying this. Should we take this seriously? That was the kind of questions we were getting at the time.
So, again, this meeting is, predates the popularity of deep learning, predates AlexNet, um, and clearly predates kind of our contemporary conversations around trustworthiness and responsibility and bias. How do you compare and contrast what you talked about then and what you talk about now, and how do they
Yeah.
interrelate to one another?
Sam, this is like the reality of where we were with AI back then. We the basic assumption my colleagues and I had as grad students and then young early career scientists uh, were along the lines of, if we can just get this thing to work, with steam coming out of it, huffing and puffing, gears rotating, it's a big success. So and the things you would build would be like small numbers of things, like a prototype or a prototype and its descendant. Um, you build like a readmissions prediction system for healthcare, and it was like you just would say, yes, it works. I get well calibrated probabilities out of this thing that a patient will bounce back in 30 days, for example, with training off electronic health records. So there's always a celebration of the goodness of getting anything to just darn work. And it was a stretch at the time to start thinking about stuff that not just worked, whether it worked poorly or not, but that would be distributed and have huge effects on the planet. Um, and so it's just a different feel for the level of influence and responsibility that became much more obvious a few years later. In fact, in 2013 or so, just 4 years later, I thought to myself, we should do this again. We should have another meeting like this and get this same group or a bigger group together, because it's getting more important now to get the scientific point of view, the scientists who are really committed, that could understand some of the problems deeply and maybe address them. And I said, okay, it will be 5 years in 2014. And then I thought, it's kind of like induction, n gets n plus 1. We should do this every 5 years for like the rest of the history of human civilization, because this stuff's going to move fast, this technology, and it's going to have a huge influence. And we need to understand our relationship with the technology. And that's when I had a discussion with my significant other. And we thought, I wonder if we could make our first bit of major, our first philanthropy, significant philanthropy, the endowment of some sort of a center that would always do a report every 5 years and make sure it happened. That would be proactive, that would look out, that would have a sort of framing of a set of core topics that would be kind of timeless in terms of concerns. And this is what led to the 100-year study that's now at Stanford. It's called the 100-year study on artificial intelligence, but it really is a study that will happen every 5 years for as long as Stanford University exists. And John Hennessy at the time assured me he thought it would last longer than 100 years. President at the time. So,
and so in thinking about, we can maybe take a detour a little bit and talk about your role at Microsoft briefly.
sure.
And because I want to explore, the ethics of, the theoretical ethics and what I imagine is much more real and tangible,
Yeah.
issues that you must encounter when talking to customers that are actually trying to do things, and uh, assessing, risk and responsibility, and things like that.
Yeah. So this work so I just mentioned some of the framing, which was the Stanford study for me, and thinking about this with our colleagues, and then
Mhm.
getting this Stanford University long-term study set up over time. And at Microsoft, there was rising interest and concerns as well, given our role in the world and how central AI was to Microsoft and to our future. And as far as I'd say the modern history of work in this space, Satya Nadella kicked off a discussion in 2016, called together a small group. And we asked ourselves, and he led the discussion, what are our AI principles? And it was a very interesting discussion, and it converged on 6 principles. It was 20 at one time and 14, but it converged down to 6, which we call Microsoft's AI principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. And we have a little internally at Microsoft, we have a little sentence, and then click through for a bigger paragraph and more detail on each one of those 6 principles that we've now socialized with the company. We have an annual training about what they mean. But that was the beginning. And then around those principles, working with Brad Smith, I set up what's called the Aether Committee. And Aether, AETHER, stood for and stands for AI Ethics and Effects in Engineering and Research. And that was the start in 2013 late 2016, early 2017 of a committee and then a set of working groups that would focus on specific topics, largely aligned with those principles. A few more. One of them was called, for your question, Sam, the Sensitive Uses Panel.
Mm-hmm.
And this panel became the body by which we would define and then roll out a process for the company to send sensitive uses for review. And even defining for Microsoft, for our processes for Aether committee, what was a sensitive use of AI technology? It was kind of an interesting endeavor in itself early on. And keeping it simple but powerful, for example. So just to give you a sense, we said, okay, a sensitive use of AI, one that should come to the sensitive uses panel for review, is if a product team is thinking about developing a product or has one out there already that is at risk of denying consequential services to somebody or a subgroup, healthcare, finance, or education, or is there a risk of physical or psychological harm, or could the technology infringe upon human rights? So a few years ago, we developed a technology, and others have done similar things that we call neural TTS, text speech. That was fabulous in that you could speak to a system, give it a few snippets of how you speak, and have a deep neural net model learn to speak like you so well that it could, if you had ALS and were losing your voice, you could rely on this instead of a machine-like text of voice to speak to your family, or have it be used to narrate in a very natural way broadcast news. Mm-hmm. It also could be used for malevolent purposes. Someone could steal your voice and have you call your bank and write a check and send it somewhere, or could feign to be a politician, a political leader, making a statement that could be very dangerous and threatening, fraudulent. So Sensitive Uses Committee deliberated and sent a recommendation to our SLT that this technology should be gated. It should not be freely available. It should be licensed under certain restrictions, such that like a news organization could license it for use. That's an example of the kind of technology that really it went through a process whereby a panel met, worked with the local expert team in our cognitive services area, wrote a report which went to the Aether board. That report was refined. Typically what's done in those reports is that there's a recommendation that's made, an alternate or one or more alternates. Each one will be a cost-benefit analysis. Here's why we're doing this. If we don't do this, here's some costs. Here's the upside, the downside. And then if it's something that has not been precedent that really needs senior top leadership of the company to look at and make a call, we take it up to the senior leaders. I have to say that I don't remember a time where the top one or two recommendations wasn't the one that was selected from the Aether committee for execution by the company.
Part of the responsibility of AI is to educate the folks that are going to use it. I imagine there's quite a lot that goes into internal communications around a effort like Aether, and training engineers to know when they should raise the flag and start to ask questions about a technology. Are there a set of educational responsibilities or things that you think that we as an industry need to be committed to from an education perspective around responsible use of AI? How do you think about that?
I think so. And this, Microsoft feels and has been running like an AI business school, trying to share these principles with partners. I'd like to see more sharing going on at the level of details among all the partnership on AI organizations, including the nonprofits, to come up with best practices and to educate about them. Education and training came up as being critical topics, and requirements for recommendations being made when it came to this. We haven't gotten to this story yet, which is the story of the National Security Commission on AI, which I just came off of, and we just fielded a report after 2 years, but it really called out the need, for training and best practices when it comes to the fielding of AI technologies when it comes to national security agencies of various kinds. Sorry to jump ahead if we would go there, but
No,
this was such a central point of the training and sort of getting people on the same page when it comes to engineering, building, fielding, reviewing these systems.
I'd love to have you share a bit about that effort and your involvement in it. Is one of the things that caught my interest, because I think there's, we think you mentioned, you didn't use the words, but you alluded to kind of smart cities as one of the ways that folks, governments want to apply artificial intelligence. And, sometimes that comes off as a euphemism for surveillance. And
Yeah.
we, I think, have we're justified in being suspicious of security and security apparatus and their use of technologies like AI. Tell us about that report, that effort, how it came about, and some of the key findings.
Yeah. So in 2018, Congress, the U.S. Congress, which commissioned this study, um, um, called for a deep analysis of AI and its relationship to where the United States is and could be when it came to applications of AI. And this panel, called the National Security Commission on AI, or NSCAI, was established in 2019. It's gone for 2 years, and on March 1st, it fielded its report. It's available at nscai.gov if you want to read the report. It's a 750 plus page report. And
So I'm forgiven for not having finished it before our conversation.
I think it's well done, and you can read the sections you want to look at with care. I was mostly involved in terms of my detailed attention on 4 of the chapters, as they're called. One on the future of R&D, where's AI heading?
Mm-hmm.
The second one on trustworthy AI and building trustworthy systems. The third on civil liberties, civil rights, and privacy of AI systems, getting into our values. And the fourth on this really interesting and challenging area that there's lots of emotion about, for good reason, AI and lethal autonomous weapons.
Mm-hmm.
These 4 chapters that I think are and the others are really lay out the ideas, directions, challenges with clarity. We put a lot of work into writing for both experts and non-experts alike. I was chair of the area we called ethical and responsible AI, which led to those 2 chapters, chapter 7 and 8, 7 on trustworthiness and 8 on, I would say, values, ethics, civil liberties. It's interesting. The original name for my line of effort that I chaired was AI ethics. But you think about what we mean by ethics, ethics often brings to mind issues of values and rights, and trade-offs and deep questions about beliefs. But there's a whole other area of responsible AI, which gets into engineering issues like uh, human AI collaboration methods, the role of the human being when it comes to working with AI systems, um, issues around security and trustworthiness, reliability. How well does an AI system face adversarial attacks? These new kinds of attacks called machine learning attacks, and so on. And so you wouldn't necessarily call those kinds of issues ethics. I would call them like, engineering challenges with robustness and trustworthiness. So we ended up splitting up that our area into two pillars. One focusing on what I would say is values, civil rights, civil liberties, which I think is very important in a report on national security agencies using AI. As you mentioned before, there's this interesting tension, and we want to be careful to know who it is that we are as the United States and our constitutional principles, and looking at issues of reliability. What I can say is, and I'm very proud of about this report, is the report really considered values, civil liberties, and civil rights and privacy as foundational to everything in the report. Kept coming back to that. And I remember when somebody in one of the plenary, we would have these plenary sessions with like public and journalists. Somebody asked a question at the Zoom meeting. Wasn't this going to be costly, all these values and all the reviews you're asking for and the oversight and the committees and the processes in place? Wouldn't that put us in a non-competitive place in the world with AI? But my reaction was, this is who we are. And it means it's going to be costlier and it may slow us down, but it's who we are. It was just quiet at that point. Because you think about it, these technologies can be dangerous. They can be oppressive. They're already being used by authoritarian regimes to oppress. And we need to be cautious and careful and provide an example to the world about a norm for how these technologies can and should be used when it comes to agencies like FBI, NSA, CIA, Homeland Security, Health and Human Services, and so on, that we were kind of looking at for the agencies that would be using these technologies.
Well, I want to dig into that report some more. And if you don't mind, I'll pick your brain as to some folks to talk to dig deeper into some of the issues that it
Oh, absolutely.
raises.
Some really, by the way, I was curious, well, how did I get selected to do this, to be what we're called commissioners? And if you look in the way that Congress wrote the charge, by the way, they said, the committee will consider the methods and means necessary to advance the development of AI, machine learning, and associated technologies to comprehensively address the national security and defense needs of the U.S. Well, you looked at why I was selected. They had a whole a list of how commissioners would be selected in the actual legislation they had on record. So the chair of the House Armed Services Committee gets to vote for one person, and that happened to be Eric Horvitz. I said, well, that's really Adam Swift. The Senate, I was actually invited directly. The Pentagon has, and so each commissioner was invited by a different agency or a different process. But it was such a wonderful group of people to work with, these commissioners. Fabulous, some long-term colleagues, some people I had just met, all pretty, deeply passionate about doing a good job and thinking through these issues for the United States.
So I want to be sensitive to the time that you've been so gracious to share with us, and maybe start to wrap up and have you share a bit about not just your vision for the future, but also how, kind of dovetailing to our conversations about citizenry, how we as citizens, scientists, developers can engage in the process at all the various levels that it's taking place: government, company, organizations. Any thoughts on that? It's a bit of a broad question, admittedly.
Yeah, I have lots of thoughts. I mean, look, I mean, I just was invited to give some opening remarks to computer science educators at the SIGSI technical symposium a couple weeks ago, which just brought, it's the largest gathering of educators. And my comment was, boy, it's great to see all this interest in computer science. It's also great to have all this influence in the world, but with great power and influence now as computer scientists, whether it be in AI or systems or networking or HCI, comes incredible responsibility now.
Mhm.
You never would think, when I was doing computer science work, we were worrying about, algorithms and getting things to work and understanding big O and so on. You would have thought that all of a sudden it's like we have to be teaching in classes now, and we are. It's been great to see the innovation going on, values and ethics and case studies. Even asking ourselves big questions like, is it okay to use machine learning to optimize clicking on an ad,
Mhm.
or how much time someone engages with a service, with a timeline, with an Xbox game? And so
Mhm.
we're getting these interesting questions that we have to start thinking about and become very mindful as engineers as we go now. That we are talking about people's lives, how they spend their time, what content they digest. Um, uh, uh, we're talking about security issues. We're talking about breaches of data potentially. We're talking about oppression versus freedom in the world. Who would have thought that computer science would have become so influential as to require us all as scientists and as engineers and as students to be thinking deeply about uh, issues that are now not foreign, but that are a deep part of computer science um, and computer engineering, whether it be in industry or in other areas. And so I think that's just, I have to take a deep breath sometimes to think of how far we've come and how important these technologies are and how important they will be going forward. Um, Only more important over time in terms of thinking through how small biases, for example, that, let's say they're small, they can be quite big, but even a small bias in how a system is working based on small biases in data that come from the way the data was collected from a biased society, as we all know, historically, could now amplify the biases en masse. And so we have those issues, the issues of uh, privacy. Data is the fuel of AI systems. Um, we know, and many of us, we get our applications on our phones, and we see some sort of no matter how privacy oriented we are, we're kind of busy people. We say, okay, sure, location, yeah, okay, I'll be
Right.
useful, and we don't realize
Convenience
that.
trade-off.
And then we see a story in the press that a government agency was able to purchase a large scale database of the location trails of people commercially, which is okay per current laws. That is a gray area in particular, I think, actually. And we see new questions coming up. What does it mean when we have large scale commercially available data about faces with names that are available in many applications that could be brought together and fused into databases that are available commercially? And so you can just walk through every one of, for example, Microsoft's AI principles. I'll say that again: fairness, reliability and safety, privacy and security, inclusiveness, transparency, accountability. You can walk through each of those 6 principles, and you have rich, hard questions, incredible opportunities for getting things right, also the ability to stumble. And so lots of work to be done.
Hmm. Hmm. Um, I'm pulling back from asking another question that
Go for it. We
we'll
maybe
pull
get
up.
a few minutes.
So in there, you mentioned HCI in passing, and I know that one of your topics of interest is kind of complementarity and kind of the way humans and AI will interact. And my sense is that that shapes a bit of your vision for how we should be developing AI. And I thought
Yeah.
it'd be great to hear you riff on that for a bit.
Yeah. So I would say that besides the deep principles of how computation leads to minds of the form that we find ourselves thinking with right now,
Hmm.
this my second most uh, uh, intensive focus has been on human AI complementarity and collaboration and the future of our relationship with AI systems. I think that we can do a lot there. We're already making some technical advances where it's design plus there's a science. For example, how machine learning can be harnessed to understand human blind spots and weaknesses and to complement people. So we work together as a team for greater wholes. I think we can design better futures for civilization, for humanity, in terms of our well-being and our labor and our work, um, by being deliberate about how we think about how we should be designing AI systems to work with people versus always thinking about an automated agent or fully autonomous technologies. That will happen too, of course, but there's so much opportunity in this space of, for example, helping physicians to recognize when they may have missed something in a patient will crash. There's a phrase in medicine I was just talking about at a Stanford symposium called failure to rescue. It means that
Hmm.
you missed something and a patient died in the hospital. And we've built systems that can actually look out 8 hours, 12 hours and say, this patient will need a life-saving intervention within 4 hours, just to alert the staff and the team. That's an example of the kinds of complementarity we can have between humans and machines, that we have a great partnership. Um, People are always going to be central in the world, and to think through what that means in terms of having supportive, nurturing technologies is going to be important. Um, we have some really fun work on design for human AI collaboration and exciting work on mathematical principles and optimizations where we change the objective function of the machine learning, the gradient descent, such that now it's considering where people are strong and weak. We just published that piece at AAAI in January, and then a piece on optimizing for teamwork in February at HCI. So it's fabulous directions.
Maybe to poke in a little bit more on that and maybe be more concrete. Just you talked about kind of this human centrism to the way we think about developing AI. Do you think, as a thought experiment, that we should have put the investment that we're plowing into autonomous vehicles to more complement, I don't know what we would call it, driver assist technologies? And should, if we, is it the case that by investing in the moonshot of full autonomy, we support or get the technology advances to the driver assist as a interim state? Or would we have, for example, reduced the number of deaths per mile or per 1,000 miles more quickly if we focused on the human computer centric model directly, as opposed to as a byproduct of full autonomy?
Well, no one would argue that having a perfectly uh, autonomous vehicle wouldn't be desirable. You can read a book on the way to Portland from Seattle, for example. But on the trajectory of where the technologies have gone and the pace, different companies have taken different approaches. So one major manufacturer has said, we believe AI should be there as safety nets and to assist drivers to drive more safely and to reduce deaths that way. Other companies have said, we're going for it. And you'll have to grab the wheel once in a while when the system shouts, but we're trying our best to go for it. It's hard to know what's the best path, but at any moment, I would think you want to take the technology that you have and think through its best use. Certainly, given the nearly 40,000 deaths in the US, by the way, it's been going up, I think, because of distraction of devices, but per year in US, and I think it's over 1 million deaths internationally per year of driving. That we need. It's a health disasters. We need assistance and safety and nurturing as soon as possible. But you wouldn't necessarily think that the goals are disparate, right? It gets into the design and the details of what we were talking about before. How do you design for really great nurturing systems that can enhance safety and let humans remain in control and still get the best of both worlds at the current technical prowess capabilities that we have?
Awesome. Well, so much more there, as has been the case with all of the areas that we've explored. But I want to thank you so much for taking the time to chat with us and share a bit about what you're working on and thinking about.
Yeah, thank you. It sounds like we need more time, Sam. So it's been fun talking.
Absolutely. Thanks, Eric.
Thank you very much.